The next one is about indices. The indices, it's about the power or the index of a number. For example, we have a cube. So a cube means a times a times a. So this is indices. This is exponent index. We call a as the base and 3 as the power or index. So if we have a to the power of 4, so a will be the base and 4 will be the index of the power. So for example, 3 to the power of 8. So that means the base will be 3 and the index will be 8. That's indices. We have some rules of indices. So the first one, if we have the same base number, in this case the base is a, so a to the power of m times a to the power of m, and then we can add the power. So a to the power of m plus n. For example, 3 to the power of 5 times 3 to the power of 8, we can add the power. So it's 3 to the power of 5 plus 8, which is equals to 13. If we have division, the same base number, the index of the same base number, so we can just subtract the power, subtract the index. For example, 15 fifth to the power of 14 divided by 5 to the power of 3. So it will become 5 to the power of 14 minus 3, which is equals to 11. The next one, if we index the power, the base to the power of m, and then power by n, so it is a multiplication of m and n. For example, 5 to the power of 2 to the power of 6. So this is equals to 5 to the power of 2 times 6 equals to 5 to the power of 12. The fourth one, if we have two different bases of numbers, a and b, with the same index or same power, we can combine the number with that power. Yeah, so the base should be different, but the power should be the same. For example, 3 to the power of 5 times 2 to the power of 5. It's 3 times 2, combine it to the power of 5. Yeah, the same power. So it's equals to 6 to the power of 5. The fifth, if we divide the two basis numbers, we can combine the division with a single power. For example, 5 to the power of 4 divided by 3 to the power of 4. This is different base, so we can combine 5 and 3 to the power of the same index, 4. 6, a to the power of 1 of 0 equals to 1. So anything to the power of 0 is equals to 1, except for a equals to 0. So in this case, a is not 0, yeah? For example, 5 to the power of 1 is 0. 5 to the power of 0 equals to 1. 3 to the power of 0 equals to 1. Negative 2 to the power of 0 equals to 1. So everything to the power of 0 is equals to 1. 7. The negative index. The negative index here means the denominator. So we put the number in the denominator. to make it a reciprocal. So a to the power of negative n is 1 over a to the power of n. For example, 5 to the power of negative 3 equals to reciprocal 1 over 5 to the power of 3. The eighth one, for the fractional index, that means it's the root. So a to the power of 1 over n is the n root of a. For example, a to the power of 1/3 is 8, the cube root of 8 to the power of 1. And for the 9, if we have the fractional m over n, so it will be the n root of a to the power of n. For example, 8 to the power of 2 over 3, that's the same as 8 squared and then cube root. Or we can say that it's cube root of 8 to the power of 2. Let's see the example. 2 to the power of negative 3. So negative here means reciprocal. So it's 1 over 2 to the power of 3. So this is equals to 1 over 8. 8 to the power of 1/3. So we can find the value by changing the 8 into 2 to the power of 3. So 8 is 2 to the power of 3, and then to the power of 1 over 3. So using the rule, the 2 to the power of 3 powered by 1 over 3, that's the same as you multiply the power. So equals to 2 to the power of 1. The third one, 16 to the power of 3 over 4. So that's the same thing. So it's 2, 16 is 2 to the power of 4 and 3 over 4. So we can multiply 4 times 3 over 4. So we have 2 to the power of 3 equals to 8. And the last one, 25 to the power of negative 3 over 2. So this is negative, means reciprocal. So it's 1 over 25 to the power of 3 over 2. And then we can change the 25 into 5 squared to the power of 3 over 2. And then we can combine, multiply the power. So it's 5 to the power of 3. 1 over 125. You can try this for your exercise. Yeah, we see the same method. Let's see to example 2. Simplify the expression. So a 1 over 3 times a to the power of 2 over 5 divided by a to the power of half. So even here we can say that we have the same base, so we can combine. Multiplication here means addition, so we can combine it, a 1 over 3 plus 2 over 5, because this is multiplication. And then the next one is division, so we just put it as a denominator, 1 over 2, and then we simplify. The top one, the 3, 1, a 1 over 3 plus a plus 2 to the power of, sorry, a 1 over 3 plus 2 over 5. So we can combine it into over 15. So 5 plus 6, so it's 11 over 15. Yeah, this is 5 plus 6, so 11 over 15 over a half. So A 11 over 15 over A half. And then using the rules again, we can A to the power of 11 over 15 divided by A to the power of half is a it's a subtraction. So we can just subtract 11 over 15 minus 1 over 2. Yeah, we subtract with the denominator. So it's A to the power of negative 30 over 15 equals to A to the power of 7 over 30. For II, A cube B square times 4 to the power of 4. So we can multiply the power. So it's A to the power of 12 times B to the power of 8. So it will be multiplied to each of the terms. And this equals to this. Yeah, we cannot do further simplification. The third one, we can express the root in the fractional power. So the first one will be A to the power of 1 over 3. This is 1. Divide by A to the power of 2 over 5. And then multiply by A to the power of negative 1 over 2. Yeah, we multiply it. And then they have the same base, A. So we can combine. This is division, so we can subtract 1 over 3 minus 2 over 5. And then multiply. So we add by negative 1 over 2. And so this is equals to 1 over 3 minus 2 over 5. And then minus with half. So A to the power of negative 17 over 30. That's the final answer. You can try this again as the exercise. Now we move on to the solving the exponential equation. So that means we have the equation in the terms of the indices, the power. So we have to solve to find the power. For example, 2 to the power of x equals to 32. So in this case, we have to express the 32 in the terms of the base number 2. So 2 to the power of x equals to 32 is 2 to the power of 5. That means in here, x will be equals to 5. Yeah, we can just take off the index. No need to cross the number 2. Again, in II, 4 to the power of x plus 1 equals to 0.25. So in this case, I can express 0.25 as a fraction 1 over 4. Yeah? And this is equals to 4 to the power of minus 1 because 4 is in the denominator. So to make it into numerator, we have to add the negative power. So 4x plus 1. So the base already the same. So that means x plus 1 will be equals to negative 1. So x equals to negative 2. Try this again for your practice. And you can check it. Yeah. The first one is x equals to 4. The second one is x equals to 3 over 5. The third one is x equals to negative 2. This one is x equals to 0. Yeah, don't forget the rules. This one is 3 to the power of 3 in here, yeah. 27 we can express as 3 to the power of 3. So the result is x equals to 9. And the last one will be equals to 4 can be expressed into 2. So that means x equals to half. Yeah. This is I gave you the answer, so you can try by yourself and then match your answer with me. Let's say example 4. Example 4, solve this equation. So we can change the form first into the number of multiplication. So this is 2 to the power of x times 2 to the power of 3. And this one, also the same, 2 to the power of x, addition, yeah, so we can change it, yeah, times 2 to the power of 3 equals to 1 plus 2 to the power of x. So I have, this is 2 to the power of 2x times 8 to the power of 3 is 8, plus 2 to the power of x times 8 equals to 1 plus 2 to the power of x. We cannot add this one. Now, in this case, we can ask how for y equals to 2 to the power of x, because all the terms contain the 2 to the power of x. How about the first one? It doesn't have the 2 to the power of x, but it has 2 to the power of 2x. So in this case, we can rearrange the number here, become 2 to the power of x squared. Yeah, 2 to the power of 2x means 2 times x. So I can swap the position, x times 2. So this is 8 plus 8 times 2x equals to 1 plus 2x. And remember, we cannot multiply this into 16 to the power of x. Yeah, we cannot do that. Yeah, so don't do this. So now we have to change the 2x into y. So we have 8y squared plus 8y plus equals to 1 plus y. So we can simplify 8y squared plus 7y minus 1 equals to 0. Now this is quadratic equation, so we can factorize. So this is 8y, y, and then we need to 1, and then to have the positive 7. So positive 8 minus 1. So y equals to 1 over 8 in here, and then y equals to negative 1. So we replace it back to the y equals to 2 to the power of x. So 2 to the power of x equals to 1 over 8 is 1 over 2 to the power of 3. So from here, I can have x equals to 2 to the power of x is 2 to the power of negative 3. So that means x equals to negative 3. From the right side, I write down here, yeah, 2 to the power of x is negative 1. And we don't have any number. 2 to the power of any number is equals to negative number. So there is none. So that means from here, it's impossible. So it's not applicable or not possible. Yeah. So that's for this example. You have to change the form into its multiplication and then change the 2 to the power of x with the y, yeah, to simply find the expressions into the quadratic expression. So it will be easier to solve, yeah, to be solved. You can try this again for your activity. And then we can continue to the example number 5. Example 5, if 3 to the power of x times y, 9 to the power of 2y equals to 7, and 2 to the power of x, 4 to the power of negative y equals to 1 over 8, calculate the values of x and y. So we have to simplify this into two equations here. So 3 to the power of x times 9 to the power of 2y can be expressed into the 3 to the power of 2. So 9 is 3 to the power of 2. we change the 9 to the power of 2y. Yeah, this is still the same, so I only change the 9. 9 is 3 square equals to 27. 27 is 3 to the power of 2. So 3 to the power of x times 3 to the power of 4y equals to 3 to the power of 3. So we can combine here. So 3 to the power of x plus 4y. 3 to the power of 3. So that means the power will be the same. X plus 4y equals to 3. That's it. And for the second one, 2 to the power of x times 4 can be changed into 2 square. So 2 square to the power of minus y equals to 1 over 8. So 1 over 8 can be changed into 1 over 2, 3. So the same thing, 2 to the power of x times 2 to the power of negative 2y, yeah, we multiply, equals to 2 to the power of negative 3. So we make it into a negative index. Yeah, so they are the same now. So it's 2 to the power of x minus 2y. Yeah, we can add because it's multiplication of the same base. Equals to 2 to the power of negative 3. So it is already the same. So that means x minus 2y equals to negative 3. Now we can do the simultaneous equation. I can do the elimination in here. So I can minus. So I can cancel the x. And 4 minus negative 2y is 6y. 3 minus negative 3 is 6. So y equals to 1. And then to find x, we can just replace it to one of them. So y equals to 1. I can put it here. 1 minus 2 times y equals to negative 3. This is x here. So x equals to negative 3 plus 2, x equals to negative 1. So that's all the values of x and y. We can try this for the practice. And now we move to the logarithms, the last topic in this discussion. Logarithm is the anti of exponential or power. So this is the inverse of the power. For example, if we have 3 to the power of 4 equals to 81. So in inverse, we can write the base is 3. So we can write the inverse into log to the base of 3. Yeah, this is the base. So we put the 3 as the base of the log. Of the 81 should be equals to 4. Another example, 10 squared is equals to 100. So the base is 10. So the inverse function will be the log to the base of 10 of the 100 equals to 2. So in general, if we have y equals to a to the power of x, a is the base, so we can do the inverse using the log to the base of a, y equals to x. X is the index. So we use the logarithm to find the index, okay, to find the power. Here are some notes to be remembered. The logarithm of 1 of any base is 0. So log to the base a of 1 equals to 0. Why? Because the inverse here, a to the power of 0 is equals to 1. Yeah, using the definition, a to the power of m equals to b, we can rewrite as log to the base of a of b equals to m. So using this definition, that means log base a of 1 equals to 0. So a to the power of 0 is 1. So that means any base number in here for the logarithm of 1, it should be always equals to 0. The logarithm of the number to the base and the same number is 1. So log to the base a of a equals to 1. Yeah, because using the definition again, the inverse function, that means this is a to the power of 1 equals to a. So anything that has the same number will equals to 1. For example, log base 2 of 2 is also 1. Log base 5, 5 is also to 1. Yeah, as long as they are the same. And then the logarithm of negative number is undefined. So we don't have the negative number of logarithm. Log minus 2, for example, this is base of 2 equals to y, for example. And then if I want to try find the y, so it's 2 to the power of y equals to negative 2 using the definition. And this is impossible, yeah, not applicable, because positive number to the power of any number cannot be negative number. Yeah, this is the notes that you have to remember. And if you see, for the numbers, for the value of log of the number a, for any number, yeah, for a greater than 1, it will be a positive result. Log for the number greater than 1, it will be a positive result. Log of 1 is equals to 0. So if a is equals to 1, that means the result will be 0. And if log a for a smaller than 1 but greater than 0, it will be a negative number. Yeah, we can see from the example. The first one, log 264. So that means I can rewrite as log 264 equals to x. So that means 2 to the power of x will be equals to 64. So 2 to the power of x equals to 64 is 2 to the power of 6. So that means x equals to 6. So the result of this will be equals to 6. This is I, log 9, log base 9 of 3. So we can equals to x. That means, using the definition, 9 to the power of x equals to 3. So 9 is 3 squared to the power of x equals to 3 to the power of 1. So 3 to the power of 2x equals to 3 to the power of 1. So x, 2x equals to 1, x equals to half. So this one equals to half. The third one, log 1 over, to the base 3, 1 over 9. So this is log 3, 1 over 9 equals to x. So that means 3 to the power of x will be equals to 1 over 9. 3 to the power of x is 3. 9 is 1 over 3 squared. So 3x equals to 3 to the power of negative 2. So x will be negative 2. See, if the number a here is smaller than 1 but greater than 0, the result will be negative. Here we can see it's proven here. And the last one, log 8 0.24 25 equals to x. So 8 to the power of x will be equals to 0.25. So that means 8 is 2 to the power of 3. 0.25 is 1 over 4. So 2 to the power of 3x equals to 2. 1 over 4 is 1 over 2 squared. So it's 2 to the power of negative 2. So 3x equals to negative 2. X equals to minus 2 over 3. Yeah. Remember that the logarithm cannot have the negative number. So there is no log of minus 2. Yeah, we don't have this value because a should be between 0 until 1 or greater than 1 or 1 for the result is 0. The law of the logarithms. We have several laws of the logarithms. The first one, if we have log to the base a of m times n, so we can separate the log into an addition. So log to the base a of m plus log to the base a of m. And you see that the base is the same. For example, log to the base of 3, 5, plus log base 3 of 2. So we can just make it into log to the base of 3 of 5 times 2. Become 10. Number 2, the log to the base a of m over n. So similar to the first one, it will be a negative. So log a m minus log base a of m. For example, log 3, 5 plus log, this is minus, yeah, 3, 4. So the base the same, so it's log 3 and then 5 over 4. And then the other law is the power. Log to the base a, m, the power of 4. So the power can move from, so it's now p log a m. For example, log 10 5 squared. So this 2 can move out. So it's 2 log 10 5. Now we can use this law to solve all of the numbers here. For example, the first one, the log 2 of 64. So we have log 2 of 64. So we can change this using the formula, using the law. So I can rewrite as log 2 to the power of 6. And then using the law number 3, I can move the power from, so it's 6 log 2. And using this rule, if we have the same base number, it will be equals to 1. So this is 6 times 1 equals to 6. So we can see that there is the same result. And then the other one, I will choose the 3, this one. So this is log base 3. 1 over 9 is 1 over 3 squared. So this is equals to log to the base 3. It's 3 to the power of negative 2. and then the power can move into the front. So -2 log 3, and log 3 is equals to 1. So same result. Yeah, so we can use this law, and you have to memorize this law. Yeah, the third law, and with the one definition. Definition is log a m equals to b. It will be a to the power of b equals to m. Okay, let's see example 2. Without using tables, evaluate log 10, 41 over 35 plus log 10, 70 minus log 10, 41 over 2 plus 2 log 10, 5. So to use the law of logarithm, we have to make sure they have the same base, and it should be a single log. So from here, I can change the last one because it is 2, not a single log. Yeah, we cannot add if this is not single log. So I will rewrite log 10, 41 over 35 plus log 10 of 70 minus log 10 of 41 over 2 plus, now we do the reverse of the rules number 3. So the power is up. So it's log 10, 5 to the power of 2. And then now we have addition and subtraction with the same base. So we can combine it. So log 10, this is addition. So we multiply 41 over 35 times 70. And then minus. Minus here means we divide, yeah? So we can divide by 41 over 2 because this is minus. And then another positive, log to the base 10 of 5 squared. So I can just combine it here, times 5 squared. So we can simplify this, log 10. I can cancel, this is 2. And 41, 41. So it's 4 times 5 squared. And we can simplify log base 10 of 100. So this is log base 10. 100 is 10 to the power of 2. So we can move the 2. So it's 2 log 10, 10, which is equals to 2. That's the example 2. You can try this for your exercise. Now, changing the base of the logarithm. The logarithm to the base 10, sometimes we don't write any number. Yeah, log 7, for example. So this means equals to the log base 10 of 7. Yeah, sometimes we don't write down the base, so but you have to remember that that means it's the base of 10. And the other one is some books using the LG. So LG means log to the base of 10. Yeah, that's the notation that you have to remember. And now we can change the base of the logarithm. So for example, I can have log a base a of b. So I can rewrite as log to the base c, the new base c of b over log to the base of c of a. So make sure that the base will be the same. For example, find the value of this. So we can change into the base of 10, for example, yeah, to solve it using calculator. So I can change log base 5 of 16 into log to the base of 10 of 16 divided by log to the base of 10 of 5. So for example, so this one is log 10 2 to the power of 4 over log 10 5. So we can rewrite as now 4 moves to the front, so it's 4 log 10 2 over log 10 5. Now we can change the 2 here into log of 10 over 5 over log 10 5. So that means we can simplify. It's 4 log 10 to the base of 10, 10 over 5. So using the rule number 2, division, so we can make it into negative. So it's log 10 10 minus log 10 5 over log 10 5. So this is equals to 4. Log 10 10 is equals to 1 minus log 10 5 over log 10 5. So now we can have 4 1 over log 10 5 minus log 10 5 over log 10 5, which is equals to 1. So that means it's 4 1 over log 10 5 minus 1. And in here, I can change it 1 over log. This is the base is 10 and 5. So I can rewrite as log of base 5, log to the base of 10 5 over log to the base of 10 10. Yeah, in this case, I don't change the base, but I use this method. So I can have 4 1 over log divided by log. So I can switch the position. Log 10 10 over log 10 5 minus 1. So equals to 4 1 log 10 5 minus 4. So this is the final answer. So in this case, because this is the base is 10, so it will be the same as before. But if we have different base, so the value can be different. You can try this too, yeah, for the exercise. And then now we solve the logarithm equation. To solve the equation, 3 to the power of x equals to 18. Before, in the equation of the power, we can express 32 in the base of 2, the number, the power of base of 2. But now we have 3 to the power of x equals to 18, which is we cannot change 18 into the base number 3. So that's why we can use the logarithm in here. Using the definition, so this is the base. So log to the base of 3 of 18 equals to x. So you can just use the calculator, and for those who don't have the calculator with the base, so you can change the base into 10 over log 10 3 equals to x. So you can just put into the calculator log 18 divided by log 3. So that means x is equals to 2.63. Yeah, so the x is now not integer. It can be a random, any number. Yeah, that's the first method using the identity. The second method that you can use is you can put the log on the both sides. So I make it into log 10, log 10. And then I can use the rule, the power can move out. So x log 10, 3 equals to log 10, 18. So in this case, I can just find x by divide the log 10, 18 over log 10, 3, which is the same as this. And then using the calculator, I can find it's 2.63. And then in here, before we continue so far, we have a special logarithm with the natural number of base. So if the natural number is denoted by e, and the value of e is 2.718 until infinite digits. So if we have the base with the natural number e, yeah, the base of the log is e. So we call the log ex as the len x. Yeah, so from this is only the names of the function, logarithm and len. Logarithm is for any base, but len it's only for the logarithm of the base e. So for example, log e3. So this is log base-nya e, and this will change into len 3 because log to the base e is equals to len. So that means, okay, I just continue. That means if I have len y equals to x, so the base is 3, is e, and then I can do the inverse. The inverse will be e to the power of x equals to y. Yeah, using the definition. Yeah, in here, you see the blue one. The definition, the base is a. So a to the power of b equals to m. In here, we will have e to the power of x equals to y. And then for example 5, we can calculate the value of p. So we see here the log has the same base already, but we cannot combine because we have 2 here. So we have to remove the 2. So this is log 10 4 plus the 2 can be carried into the power. So it's log 10 of p squared equals to 2. So we have the same base. Now we can combine. It's log 10 4 times p squared equals to 2. So that means it's log 10 4 p squared equals to 2. And using the definition, we can make it 10 to the power of 2 equals to 4p squared. So 100 equals to 4p squared. So p squared equals to 25 and p equals to plus minus 5. But please be noticed that in here, p cannot be negative. So that means we only have the positive 5 value. Yeah, ignore the negative. Because we cannot have negative number inside the logarithm function. Okay, you can try again for the exercise. And this one, we can, the same, I have to remove the 2. So it's log 10, 3x plus 2 minus log 10x, move it to square, equals to 1 minus log 10, 5x minus 3. So from here, I can combine log 10 minus is division, 3x plus 2 over x squared minus 1. 1 can be changed into, oh, this is equal, yeah? 1 can be changed into log to the base of 10. 10. Because we have base 10 here. So minus log 10, 5x minus 3. So we can combine again. This is log 10 of 10 over 5x minus 3. So this is still the same. And now we can, because the log 10 of this equals the log 10 of this, so we can remove the log 10. So equalize the term inside the log. So we have cross multiply 3x plus 2, 5x minus 3 equals to 10x squared. So 15x squared minus 9 plus 10 plus x minus 6 equals to 10x squared minus 6. So we can simplify 5x squared plus x minus 6 equals to 0. So this is 5x, x, 6 and 1. So minus 5 plus 6. So x equals to negative 6 over 5. Or x equals to 1. In this case, we have log x here, so x cannot be negative. So ignore this, not applicable. So the answer should be only x equals to 1. If you check, if you put x equals to 1 here, it will be positive. X here, 1 equals, x equals to 1 here, it will be also positive. So that will be fine. You can try this again for the exercise. Okay, that's it. So that's all the rules of the logarithms. And this is the end of this video. Thank you for watching and keep practicing because maths needs practice. Thank you and bye.